Hello and welcome. In today's session, we're going to be continuing our trigonometric series. This is part 3 of the series where we will be solving questions related to the last part. So I'd highly recommend, if you didn't watch part 2, go ahead and I will leave the link up on the right corner for you to go watch that part and then come and continue part 3. So we're basically talking about trig identities. So in today's video, we're just going to be solving questions on trig identities. So I have a bunch of questions here, and I also, for reference, have this formula, which I will leave in the description as a link so you can use it. Okay, so these are the identities grouped into all the names. Okay, so let's start by trying to attempt question 1. So basically, questions say prove each identity. So I need to prove that secant x minus tan x sine x equals 1 over secant x. I know from my identities that secant x equals 1 over cosine x. And I know that cosecant x equals 1 over sine x. And I know that cotangent x equals 1 over tan x. Okay, so let me try and rewrite these in the sine and cosine forms. Okay, so secant x is going to be 1 over cosine x minus, okay, I know that tan x equals sine x over cosine x. Okay, so I will write it at that. So sine x over cosine x, and we have a multiplying by sine x. This all should be equal to 1 over cosecant x. Okay, if, secant x. Okay, if secant x is 1 over cosine, so 1 over secant x is basically the reciprocal of secant x. So the reciprocal of 1 over cosine. So it's cosine over 1 or cosine x. Okay, so now I have a fraction, subtraction, and I have common denominators, so I can subtract these. So I will have a 1 minus, okay, sine x times sine x is going to be sine squared x, and I will have a common denominator of cosine x. Okay, this should give me a cosine x type. How do I move on from here? Type from my Pythagorean identities, I know that sine squared theta or sine squared x plus cosine squared x equals 1. So that makes cosine squared theta equals, I will move the sign to the other side, equals 1 minus sine squared theta. And if I look here, I exactly have a 1 minus sine squared theta. So I can replace this with a cosine squared x over a cosine x, and this should give me cosine x. And I know that by dividing 1x, 1 cosine x will go from the top and it will divide by the one on the bottom. So on the left I will have a cosine x, and on the right I'll have a cosine x, and this is how I proved this identity. So let's move on to the next one. Okay, so let's rewrite this. Okay, and again let's change these into the sine and cosine form. Okay, so we have a 1 plus cosine x over sine x equals, okay, I know that cosecant is 1 over sine x, and I know that cotangent is 1 over tan x. So if I have tan x equals sine x over cosine x, cotangent is 1 over tan x, so it's the reciprocal of tan x. So it's reciprocal of this. Reciprocal means the fraction flipped. So it's cosine x over sine x. So cotan is going to be cosine x over sine x. Okay, and then I will have this part on the left side. I will not do anything to it, and then I will add my fraction. I have common denominator, so I can add the numerators and just copy the denominator as sine x, and when I add them I will find a 1 plus cosine x, which is exactly the same as this. Okay, hope everything is okay. Now let's go to a little bit more difficult question. Okay, so we have a secant theta times sine theta over tan theta plus cotangent theta equals sine squared theta. Okay, so let's try and rewrite everything in the sine and cosine form. I like doing this. So I have this fraction, which is this. Okay, on the numerator, I'll have a secant theta, which I can rewrite it as 1 over cosine. I just like to work with x. Let me say let theta equals x, so we're not confused. I'll just work with x. It's better for me. Okay, and then I have a multiplication of sine x, and that is over, okay, tan theta. I know that tan x is sine x over cosine x, plus cotan is basically the reciprocal of tan, so it's going to be the reciprocal, so it's cosine x over sine x. Okay, so let me multiply the numerator. I will have a sine x over a cosine x in the numerator, and all of this over this fraction right here. Type. I cannot add this fraction now because I have different denominators. I know that to add fractions, I will need a common denominator. So what I can do is multiply here up and down by sine x over sine x. Why do I do that? So, and here as well, I will multiply by cosine x over cosine x. Why am I doing this? To make sure that the denominators are the same. And you're looking at this left part, the denominator now is going to be sine x times cosine x. And looking at the right part, the denominator is going to also be sine x times cosine x. And in order to multiply the denominator, I will need to do the same for the numerator as well. So let's try and move on from here. So, okay, let me erase this and just maybe write it down. So this is multiplying cosine x over cosine x. Okay, so sine x times sine x is going to be sine squared x. Okay, and over sine x cosine x. And then I have a plus. I will have cosine times cosine is cosine squared x over, I will have sine x cosine x. So if I want to add them, I will basically add the numerators and copy the denominator. So I can do that really quick. I know that the denominator is going to be the same. So I can do something like this. I'm adding them. So plus and then over the common denominator. Let me just try to move it slightly. Yeah. So this is what I will have till now over here. Okay. So let's try to move on from here. Okay, let's do something like this. So I know, okay, let me copy this. Okay, and move to a better place. No. Okay, type. Let's continue from here. Let's continue. Let's actually continue here. Okay, so this means that I have the numerator divide the denominator. So let me write the numerator as sine x over cosine x, and instead of this big divide line, I'll just write it as divide this. So it's divide sine squared x plus cosine squared x over sine x cosine x, right? That I know instead of divide, I can erase this divide, write it as a multiplication, and flip this around. So what's on top becomes on bottom, and what's on bottom becomes on top. So let me do that really quickly. So I can do something. Yeah, so I will erase this, I'll make it a multiplication, and then I will flip this whole thing. Okay, so let's erase it. And let's flip those around. So the denominator will be on the top, so it will be sine x cosine x, and the numerator will come down, so it's going to be sine squared x plus cosine squared x. Okay, and I'm multiplying those two together. So looking now, I can cancel a cosine x with this cosine x, and then I will multiply the numerator. So this is going to give me sine x times sine x, which is sine squared x, over sine squared x plus cosine squared x. And from my trig identity, I know that sine squared x plus cosine squared x is basically 1. So this is going to give me a sine squared x over 1, because this is equal to 1. So it's basically sine squared x, and I've now proved that this left side at the end is going to equal sine squared x. Okay, so let me erase all this. So let's just get rid of this part so we can work. Okay, I hope everything's clear now, and let's move on to the next question. So let's take a look at this question. This says secant x over cosine x minus tan x over cotangent x is supposed to give me 1. So let's see how I will solve this one. Okay, so let's rewrite them again all in the sine and cosine form. So secant, I will write this fraction first. So this is the line. Secant is basically 1 over cosine x, and this I have a cosine x. And then minus, instead of tan, I will write as sine x over cosine x. And instead of cotangent, I will write a cosine x over sine x. Okay, so basically, this is going to be 1 over cosine x divide cosine x, or I can rewrite it as multiply 1 over cosine x, correct? So this is going to give me 1 over cosine squared x, this part, and then minus, I will do the same here, so I will do a sine x over cosine x dividing this denominator, which is the same as multiplying the reciprocal. So I will multiply the reciprocal, which is sine x over cosine x. So from here, I can deduce that 1 over cosine squared x minus, I will have a sine squared x over cosine squared x, which is basically sine squared x over a cosine squared x. I will see that I have a common denominator, so I can continue with the subtraction of the fraction. So I will just write the common denominator down, which is cosine squared x, and I will have on the top a 1 minus sine squared x. And again, from the trigonometric identity that says that sine squared x plus cosine squared x equals 1, I know that cosine squared x is going to equal 1 minus sine squared of x. So this part could be replaced with a cosine squared of x would be replaced with a cosine squared of x over a cosine squared of x, which is basically anything over itself is basically a 1, which is going to give me the one that I was looking for to prove this. Okay, let me continue to the next questions. Okay, so these are basically the same type of questions, so we need to prove that the left side is equal to the right side. So let's try doing this first equation here. So we have, let me just copy it here. So we have a 1 plus sine 2 theta equals, I guess we're working with theta this time, plus cosine theta squared. Okay, so let me prove this. Okay, so looking at this sine 2 theta, okay, I know that my angles are not the same. Yani sine theta cannot be equal to sine 2 theta. So on my left side, I have a double angle 2 theta, and on my right side I have only theta, so this is a different angle. So I need to work on something that will reduce this double angle to things in terms of only theta as the angle. So I will look at my double angle identities. I will find that sine 2 theta is equal to 2 sine theta cosine theta. So let's rewrite sine theta as 2 sine theta cosine theta, and this reduced from a double angle to a single angle, kind of. Okay, and now let's expand this power. So expanding is going to be the same as sine the first squared, so it's sine squared theta plus first term times the second term times 2. So sine theta times cosine theta is sine theta cos theta times 2 is 2 sine theta cos theta plus the last term squared, which is cosine squared theta. And by the way, if you don't like this way, you can basically solve it as sine theta plus cosine theta multiply itself, because that's what squares mean. And we can just work it out like this. So sine theta times sine theta equals sine squared theta. Sine theta plus cosine theta is plus sine theta cos theta. And then a cos theta times sine theta is basically again a sine theta times cos theta, or the other way around, doesn't matter. And then I'll have a plus cosine squared theta. I find that these two, I can add them up. I'll have a sine squared theta plus 2 cosine plus 2, let's rewrite it as plus 2 sine theta cos theta, which is the addition of these two, plus a cosine squared theta, which is what I have here exactly. So coming back to this, I know from my Pythagorean identity that sine squared theta plus a cosine squared theta is 1, so I can replace these two with 1, so I will have a 1 plus 2 sine theta cosine theta, which is exactly the same as this left side over here. Okay, so this is for A. Let's solve B over here. Okay, so B tells me that I have again a double angle sine 2 theta equals 2 cotangent theta sine squared theta. So let me start by, because on the right I have only theta as angle and on the left I have a double angle. So let me rewrite this using the double angle identity. So it's going to be 1 plus 2 sine theta cosine theta on the left side. And then on the right side, instead of cotangent, I know that cotangent is cosine theta over sine theta, and then multiplying a sine squared theta. So I can find that I can simplify a 1 sine here can go from this with this sign, they will cancel out, and I will have a 2 cosine theta times sine theta on the left side. So this is basically 2 cosine theta sine theta, and this is 1 plus sine theta over cosine theta. Wait, where is B? Yes, it's cotangent. So we have 2 sine. Wait, I wrote the identity in the wrong way. I wrote the identity in the wrong way. Sine 2 theta is not 1 plus 2 sine theta cosine theta. It's just 2 sine theta cosine theta, and then that's why that was the error that was happening. And I will find now by doing this that the left side is exactly 2 sine theta cosine theta, and this is also 2 sine theta cos theta, or cos theta times theta. It's the same thing. Okay, so now let's try to do question C. Let me try and rewrite it here over. So I know that cosine 2 theta equals a 1 minus tan squared theta over 1 plus tan squared theta. So this is an interesting one. Let's try and solve it together. So let me see that again. Here on the right I have a single theta as an angle, and here I have a dual angle. So I will look into reducing this into a single angle. So I can look here, I can find that the cos 2 theta is going to equal a cosine squared theta minus a sine squared theta. So let's replace that with a cosine squared theta minus a sine squared theta. Okay? And let me rewrite this fraction in terms of sine and cosine. So this is going to be 1 minus tan squared is basically sine over cosine all squared. So if I distribute this power, this will give me a sine squared over cosine squared. Okay, and let's do the same for the lower part. So it's going to be 1 plus sine squared theta over cosine squared theta. Okay, let's try to add this one and, sorry, subtract sine theta over cosine theta from this one and add it to this one. So we will need a common denominator. So let's start by looking at the top part. So to make this one a common denominator, I can multiply up and down by cosine squared theta. So cosine squared theta over cosine squared theta. This is exactly the same as 1, so I didn't change anything. Okay, but now it allows me to add, since now I have the common denominator of cosine squared theta, so I can do something like this. So I can just subtract them and then do this. Let me get this here. So I will have, okay, I guess will leave it like this. No, let's rewrite it better. So all of this is over a cosine squared theta. And then we can do the same in the bottom. So it's a cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. Now, since they have the same denominator, I can add them together and put the same common denominator, which is cosine squared theta. So this is what I have till now on the right side. So this I can rewrite as, so the first part is going to be, the top part is basically the same as saying that I have, okay, a cosine squared theta minus sine squared theta over cosine squared theta, and then this whole thing is dividing, okay, and instead of dividing, it's dividing this whole thing, and instead of writing dividing this whole thing, I will just write it as multiplying the reciprocal of this whole thing. So it's going to be cosine squared theta over cosine squared theta plus sine squared theta. Let me erase this. So this is what I have now on the right side. And now I can find that cos squared theta and cos squared theta, they cancel out. And I know that from my Pythagorean identity, cosine squared theta plus sine squared theta is 1. So I can rewrite this whole thing as cosine squared theta minus sine squared theta over 1, which is basically exactly the same as the left side over here. And this is how we proved these two. Okay, perfect. I hope everything is clear. Now let's take one more question, okay, which is a different type of question. Let's try and solve this equation. So by solving is basically finding the missing item. So solving for theta means that I need to find an actual values of theta. So here it gave me the equation 4 minus 4 sine squared theta equals 3, and it gave me a range. Okay, so my range says that theta can only be within this range. It can only be 0 to 180, including 0 and including 180. So if I got an answer as theta equals 181, I will discard it as it's outside of my range. Okay, and the same if I got an answer, let's say, of negative 180, negative 90, negative 1, because it's outside my range. Okay, so let's start and solve. So right away I can see that I can take a 4 out. This is going to give me 1 minus sine squared theta equals 3, and I know 1 minus sine squared is basically cosine squared theta. So solving for theta, I will divide both sides by 4, and this will give me a cosine squared theta equals 3 over 4. Now I can take the square root of both sides. This will give me a cosine theta equals plus or minus root 3 over 4. I can rewrite it as root 3 over root 4, which I can rewrite it as root 3 over 2, because root 4 is 2. So it's a plus or minus root 3 over 2. So basically, what does this say? What do you mean by a plus and minus? It means that I have one answer where cosine theta equals plus root 3 over 2, and one answer where cosine theta equals minus root 3 over 2. So we will solve both of these angles. This will give me two answers, not only one. So to solve this for theta, theta is going to equal inverse of cosine of root 3 over 2. This is going to equal, if I put it on my calculator, shift cosine of root 3 over 2. This is going to equal 30 degrees. And here theta similarly is going to equal cosine inverse of negative root 3 over 2, which if I put in my calculator, shift cosine negative root 3 over 2 is going to give me 150 degrees. And now I'm setting my calculator in degrees because it gave me the range in degrees. Sometimes it could give you the same range as this pi. So this is exactly the same because 180 equals pi. So now I know that I will need to solve radians. Okay, so these are my two values. So now I would like to show you what does this mean, or a simple idea that we will be going through in depth for the next video. Okay, so my range was specified that it was from 0 degrees to 180 degrees. Okay, now cosine, sine, and tan, and all the trig functions are repeating functions. What do we mean? I will illustrate that by drawing, let me try and draw a cosine graph. Okay, so cosine theta, this is y, this is theta. Okay, theta is on my x-axis and y is on my y-axis. I know that my cosine looks something, let me draw it better. So my cosine theta looks something like this. So this is basically one cycle of cosine. Okay, if I wanna continue, I can continue this to give me the next cycle of cosine. So this is basically two cycles, and we know that this right here is 90 degrees. This part right here is 180 degrees. This right here is 270 degrees, and this part is 360 degrees. So cosine repeats every 360 degrees or 2 pi. And by the way, the range here was specified as 0 to 180 degrees. It could give me the range as 0 theta to pi. Pi is 180, and I believe we talked about this. Okay, so let's continue from. So what does cosine theta equals plus root 3 over 2 means? It means that I need to solve for the values of theta on the x-axis that will make my function equals the y of root 3 over 2. Okay, so root 3 over 2 is equal to around 0.866. You can use your calculator to make sure. So I know that a cosine is from 1 to this right here is minus 1. So 0.8, let's say, is around here for simplicity. So this part is the root 3 over 2. Okay, and here is negative root 3 over 2. So if I extend this line, okay, I can find that my graph or my cosine is going to have a y value of root 3 over 2 at multiple locations. This is what I mean because it's repeating. It will have multiple locations, okay? If I didn't specify a range, so from here to infinity, okay, I will have infinite solutions because it will keep repeating, right? But that's why we have a range. So my range was from 0 to 180 degrees. Okay, so how many times from 0 to 180 degrees does my graph give a root 3 over 2? I can see that's only one time here. Okay, so you can tell me, okay, there is another point over here. Why is this not wrong? This is not wrong, okay, but this is outside of my range because I can clearly see that this is more than 180 degrees. Okay, if for example my range was 0 theta to, let's say, 720 degrees, okay, I would tell you, yes, this is a correct answer, and we will have two answers. Okay, type. Why does the calculator, when you try and solve it, it gives you the first answer, which is 30 degrees, which means that this here is 30 degrees. Calculator always gives you the first answer. But how do you find the angles that are also intersecting and are the other solutions. This we use the Aztec rule, which we will go through next video. So please consider subscribing and putting on the notification so you don't miss it out. Okay, so let's keep in our equation right here in our problem. Okay, so now we know that in the range theta is 30. The next theta is going to be outside of my range, so خلاص my theta for this first part, the answer is going to be 30 degrees. And for the second part, okay, for the second equation, because remember we had two equations, cos theta equals negative root 3 over 2. So for this one, I will extend this line. I will find that it touches on this point and on this point. However, this point is out of range, so I will not include it in my answer. So it's only this point, and when we calculated it, we found that it was 150 degrees. So our answers are 30 degrees and 150 degrees. These are the answers for this question. Hope you benefited. I thank you so much for watching. I'd encourage you to like and subscribe, and please feel free to comment and suggest anything you would want below, any topic or any specific problem, and I'll make sure to read them all and hopefully do videos on the topics you find challenging. As I said, don't forget to subscribe, and thank you for watching, and have a good day.